this was section 4.1, the very beginning. What are you guys doing?
You don't have a pencil.
Do the same pencil.
So how do we know if things are a polynomial? Terms, we have multiple terms. What kind of exponents do they have to have? They have to be positive. Can they have whole numbers? So we can't have fraction exponents. We can't have negative exponents. We can't have a variable under a radical or a variable on the bottom of a fraction. So is this one a polynomial? No. Oops, I started right polynomial. And the reason is that x to the 3/4. You can't have that. Is B a polynomial? Yes. Okay. Let's practice the degree and in behavior. So we had to do that in these earlier sections, but we're still using that throughout 4.3. On your quiz, you'll have to graph some polynomials. So I will ask you to give me the degree and the in behavior. So your degree is saying how many zeros do we have? Or if we multiply this out, what would be our highest power of x? 4. In behavior, if it's even degree, it looks like a parabola, but there's a negative in front, so it would be. Is C a polynomial? Alright, careful. What's our degree? 5. I flipped the order on you. The highest power of x is the next to the 5th. In behavior, so we have to look, that's a negative 2x to the 5th. Odds look like a cube, but because it has a negative coefficient, it would be flipped, so up, down. Alright. Is D a polynomial? What would be my degree? We have to think about if we multiplied it out. What would be the end behavior? Alright, so the pieces from that would specifically be on tomorrow's quiz are degree and end behavior, because we had to list that out before we graphed any of those polynomials. Okay, questions there? In 4.2, we talked about some of the properties of the graphs. We had a question kind of like this on our last quiz. The minimum possible degree. 4. How'd you get it?
3 curves.
Yeah, it's always one more than the number of turning points, so we changed direction 3 times. Or you could think, I didn't put an x-axis here, but if I drew an x-axis, I could draw one that hit this 4 times, so it has to be at least degree 4. Domain. Alright, keeps going both directions. Range. Yeah, it's point AB, so the y value of that is just B. Okay, then we did local max and local min. So, local max, any points that are higher than the points surrounding them. What would that be? AB is 1. Alright, local min, is there a point that is lower than the points surrounding it? Okay. So local max and mins, you can have multiple. Absolute max and min. Absolute max, I need the single highest point on this graph. Absolute min, the single lowest point on this graph. There is none because it keeps going down forever. Okay, so those questions will not specifically be on tomorrow's quiz. They were on our last quiz, but I'm trying to just keep hitting some of this stuff so we don't forget it. Questions there? the next one, I could ask you something like this on our quiz, because we've talked a lot about what our polynomials might look like. So degree 8, that means we have to have, if negative 3 is a 0, what goes in my factored form? That was multiplicity 4, so what does that mean? You have either write it 4 times or just do to the 4th power. 1 is a 0, so we need, and the multiplicity of that is 3. Third. And 0 is a 0. So you could put x plus 0, x minus 0, or just a plain x. And I put it in front, but it certainly doesn't have to be. You just have to have it in there somewhere. Is that a total of 8 zeros in there? Okay, so we've met that requirement. Right, number 4. I want to write the equation that matches this graph. So, what's the first place where it hits the x-axis? So what would have to be my factor?
X plus 2 squared
Good, absolutely. Where else does it hit? 3. So alright, the only other thing that this could have is some number out in front. So this was, again, section 4.2, so not on tomorrow's quiz, but when we come time for the test, we'll still have these. So we need to be able to find that number out in front. We can use our y-intercept to do that. That is the point 0, 4. So it's saying when my x is 0, this whole thing equals 4. So 0 plus 2 is 2, square root is 4. 0 minus 3 is negative 3. Divide by negative 12. So that coefficient is a negative 1/3. So our final polynomial is negative 1/3 times x plus 2 squared x minus 3. So far, so good? Next, how do you find the quotient? Synthetic division. What number would go out in the box? Negative 4. Okay. Now, what am I going to have to put for my coefficients? And we have the 0x and the negative 16. So 1 comes down. 1 times negative 4 is negative 4. 0 plus negative 4 is negative 4 times negative 4 is positive 16. Negative 16 plus 16 is 0. 0 times negative 4 is 0. 0 plus 0 is 0. And 0 times negative 4 is 0. Plus 1 is 1. 1 times negative 4 is negative 4. And that gives me a 16. So, my quotient, how would I write this? We have a 0x cubed and a 0x squared, so we could leave those out. Good. Is this a factor?
No.
I just want to know if x plus 4 is a factor. So no, we can't factor this nicely yet. But was x plus 4 a factor? Yes, it's a factor if it divides it evenly, if there is no remainder. Okay, that was kind of old stuff too. But the next question is new stuff. So we could have this on tomorrow's quiz. So we learned the degree tells you how many zeros you can have. I gave you some of them. I want the remaining ones. So 3 is a 0, that's fine. But if 6i is a 0, what else has to be?
Names.
If negative 4 minus I is a 0, and if 3 plus 5i is a 0, I said degree 8, that just means we have 8 total zeros. 3 was a 0 twice, so there's 2, 3, 4, 5, 6, 7, 8. So we've got them. So just knowing that those imaginary zeros come in pairs. If you have one, the conjugate has to also work. So that's an easy question that I will probably put on that quiz. Alright. Then the back side. This is stuff that will be on our quiz. Drawing the graphs. So I'm not just going to give you a question and say draw the graph. I'm going to break it down like this. I'm going to ask you 6 things with it, or 5 things. The degree. So if I multiply this out, what power would we have? 5. Okay, what is the end behavior of this graph? Good. Degree 5, so it looks like a chair, the negative flips it. And you know you can always confirm that with your calculator. The zeros in multiplicity. So what makes x minus 1 0? 1, and since it was squared, okay, what makes x minus 3 0?
3 multiple 2.
And x plus 4?
-4.
Okay. Then I'm going to ask you if the graph would go through or bounce at each of those. So you're looking at the multiplicities. And even multiplicity means what?
Bounce.
So it'll bounce at 1, bounce at 3, and go through negative 4. How do we get the y-intercept?
Put zeros.
So 0 minus 1 is negative 1 squared, 0 minus 3 is negative 3 squared, 0 plus 4 is 4. So what do we get? I think it's negative 36, because that 3 is squared. Then you have to plot all this stuff. So if you do all this, but then you just look at your calculator and do something like that for your graph, you get no credit for it. Okay, you have to actually plot the stuff we found. We know the graph should start up here and end down here. The zeros are where you hit the x-axis. So we hit the x-axis at negative 4, positive 1, positive 3. The y-intercept is where we hit the x-axis. So I'm okay with these bigger numbers if you want to just put your tick mark and label it, but don't just put a random mark with no label. Okay, so make sure you're labeling that unless you count by ones all the way down to negative 36. So then we know our graph started up here. At negative 4, does the graph bounce or go through? That goes through.
Through and then bounce.
So it bounces here. It's here and bounces and ends up going down, which is the direction we said. Make sure your final graph is curved, so it's not just a bunch of zigzags. Make it curved, adjust it if needed. And you can always kind of double check. We talked about using the calculator and kind of making sure that our shape seemed appropriate. So you'll have one like that on your quiz. Is that okay with everybody? And like I said, you don't have to memorize the steps. I will specify exactly what I want you to do. Then, so the next one is very, very similar, but I didn't factor it first. Can you guys tell me by looking at this how many zeros it should have?
Should have 4, 2, 3.
3. The number of zeros is your degree. So my maximum number of zeros is 3. My degree is 3. Those things match. What's the in behavior?
Down, up.
Alright, so since this one is not factored, I will tell you to list all of our possible zeros. So that is what we did yesterday. We have to do the P, the Q, and the possible zeros. Okay, so where do we look for the P value?
-12.
Okay, so everything that goes into 12 evenly. So you could do 1 times 12. You can do 2 times 6. You can do 3 and 4. Each of those gets a plus or a minus. Q comes from the leading coefficient, which was 2. So that would just be 1 plus or minus 1 plus or minus 2. How do we get the possible zeros?
Divide.
Alright, P over Q. So 1 over 1 is 1. 1 over 2 is 1/2. Each of them gets plus and minus. 12 over 1 is 12. 12 over 2 is 6. 2 over 1 is 2. 2 over 2 is 1, which I already have. 6 over 1 is 6. 6 over 2 is 3. 3 over 1 is 3, we've got that. 3 over 2. 4 over 1 is 4. And 4 over 2 is 2, which we already have. So this is a list of everything that could work. That's what we did yesterday. How did we narrow down that list?
By all of those zeros.
How did we know which one did work? What did we look at? Yeah, let's graph that original and see if we can tell when that does work. So we would like a nice point that we could tell for sure where it hits the x-axis.
-1.
Positive 3 looks like it to me it's somewhere between 0 and -1. Let's try 3. Did you plug in your function? Do you have the same graph?
Conjunction.
Okay. How will we know if we got the right 0?
It comes out to be a 0.
Yeah. If we don't get a 0, then we need to try something different. So we do synthetic here. Hopefully I left you guys more room on your paper than I did on mine. So we're on part E now, finding the actual zeros. So we're going to do our synthetic. So that did come out evenly. What are we going to have to do now?
Do it again.
You have 2 options. You could go back and do it again. Usually once we got to a quadratic, we just did box method, but you would certainly be welcome to find another 0 and do synthetic. Multiply to 8 and add to 9. So that would be 8 and 1. So we get 2x plus 1, x plus 4. So the zeros. What makes 2x plus 1 equal 0? -1/2. What makes x plus 4 equal 0? -4. And what's the other one we need?
3 is minus 35.
Yeah. If you were putting the x's with it, it would be x minus 3. I just asked for the zeros, not the factors, so we just need the number. Guys, you can check these on your graph, but I'm telling you right now, on the quiz, if you just write down the zeros from your graph without doing the possible zeros and the division, you just lost about 10 points. So, show your work. The graph is there as a resource, but I don't want you relying on it too much, because I'm giving you nice problems where the graph can help, but we saw some yesterday that had imaginary zeros and the graph can't help us find those. So that's why we have this process. Alright, will it go through or bounce?
It would go through.
They all have a multiplicity of 1. 1 is odd, so it goes through all of them. Y-intercept. We plug in a 0 for x. We could do that at the very beginning. So you would get 0 plus 0 minus 12. So now we graph this. We know it should start down here, end up here. We hit the x-axis at -4, -1/2, and +3. Y-axis at -12. And we said it went through all the zeros. So that means it starts, hits this, goes through, comes back and hits here. Gotta hit our Y-intercept. Come back and hit this one and keep going. Does that appear to match the graph we had on our calculator?
Yeah.
Okay. So we'll have one like that where we have to use the P's and Q's to factor it on the quiz. One last problem. So this is one where I gave you the first 0 and we have to find the remaining ones. But it's a little bit different because what kind of first 0? I gave you an imaginary one. There was some, or one at least, like this on the Math Excel yesterday. So it's good to go through. If I give you the first 0, what do you do first?
Synthetic.
Okay. So 3 comes down. 3 times 3i.
9i.
Can you do -1 plus 9i?
No, ma'am.
So we keep. So now what I have to do is 3i times -1 plus 9i. So you just review. 3i times -1 is -3i. 3i times 9i is 27i squared, which is, so we get -3i minus 27. Now that's good for us. The 27's dropped, so we just have -3i. So 3i times -3i, -9i squared, which is 9, and gives us a 0. Okay, this is pretty ugly, so how does that help me?
Do
Negative 3i.
Yes, if you have an imaginary 0, the conjugate also works. So we're going to take our answer and the conjugate. So 3 comes down. 3 times -3i is -9i. Add and we get -1. -1 times -3i is +3i. That gets me 0. So that's my remainder, my constant, and my x. So this is 3x minus 1. So my remaining zeros. I gave you 3i. What else worked?
Negative 3i.
-3i. And what makes 3x minus 1 equal 0?
1/3.
And that would be my final answer. Feel like you are prepared? Know what I'm going to ask tomorrow?
Yeah.